In this video clip, we will talk about more details for function domain. In the previous lecture, we have talked about the definition of a function. There we have talked about domain and range. So in this lecture, we will talk about domain. Right here, you see this is a set notation for variable x in between a and b, and here a and b are included. So this is a set notation. And here, this one correspondingly is an interval notation. Okay. And then here you can see for the interval notation, we have two square brackets, which shows two boundary points are included. And then on the x-axis, we have solid points for A and B. It then tells us that boundary points are included. If two boundary points are included, then we call this is a closed interval. Okay, closed interval. So let me highlight that. All right. The second case will be two boundary points are not included. Then you use round brackets on two sides. And such an interval is called open interval. Okay, and is denoted by x greater than a, less than b. Again, this is a set notation. Okay. Sometimes we have a left boundary included or right boundary included. So in this way, you want to mark left-hand side is a square bracket, or here right-hand side is a square bracket. But the point which is not included, you got to use round bracket. You see right here. And then in this case, we say interval is a half open and half closed interval. Okay, so right down here, you may write in this way. Be careful, here is greater than or equal to, then corresponding to this solid one. Similarly for here. Okay, b is included, so less than or equal to b. Solid point, square bracket. Those are the details. Then for the real number r, it then can be expressed in this way. From negative infinity to positive infinity. The sign here means infinity. Be careful here is that when you use infinity, you need to use round bracket. Because negative infinity and positive infinity, they are not really 2 points. They are not included anyway. Okay, that's a little bit delicate. All right, so Here are the 4 exercises for you to do. Okay, x greater than or equal to a can be written in this way. A is included. If a is not included, you got to use round bracket. Recall right here what's the meaning for this symbol. It means belongs to. It means belongs to. Okay? X belongs to this interval. Okay. And then for x less than or equal to b, you may write in this way. For x less than b without equal to b, you may then write in this way. Round bracket. Okay. Now let's see a few examples right here. Move up to see the example. The first example is, given this function, ask you to find out the domain and then find out the function values. Okay. What is the domain? Inside the radical sign, there is an expression x plus 2. So it requires x plus 2 needs to be non-negative. Both sides subtract 2. It then gives us x greater than or equal to -2. Okay? So then x belongs to from -2 to infinity, based on the definition we had before. -2 is included, so you use the square bracket. Okay, that's the requirement from radical expression. For rational expression, denominator cannot be 0. Because if denominator is 0, then the rational expression is not defined. X minus 1 is not 0, so x cannot be 1. So combining those two restrictions together, on the real number 9, you have 0 here, -2 here. So from -2 to the infinity, but this point 1 is not included because x cannot be 1. And then from this point to the right. So basically, the domain will be the union. From -2 is included, so solid point, to 1 round point. Union from 1 is not included, to the positive infinity. Union means what? Put those two together. Okay, that's the function domain. For question 2, it might be easy. You may just plug in -1, and where x was, you replace x with -1. So here was x, here was x, and here was x. Okay. -1 plus 2, you have a +1. And then -1 divided by -2 right here is +1/2. And then 1 minus 1/2, you have a final answer. So that's the solution for x equals -1. Now, x equals 3/2. Then x equals 3/2, you want to substitute 3/2 for x. Okay. 3/2 plus 2, you got to do is 2 equals what? 2 equals 2 times 2 over 2, because this is 1, Then you have a 2 times 2 is 4 over 2. So 4 over 2 plus 3/2, you have a 7 over 2 inside radical sign. Upstairs is 3/2, downstairs is 3/2 minus 1. So 3/2 minus 1 is 3/2 minus 2 over 2, which is 1/2. 3 minus 2. So that's how we got 1/2 here. Okay. Then the radical, let me write here. Radical 7 over 2 is radical 7 times 2 over 2 times 2, which is 14 upstairs. Downstairs is 2 squared. That's how you have a radical 14 upstairs. Downstairs is 2. So we got this one. And for 3/2 divided by 1/2, that's 3/2 divided by 1/2. You flip it. That will be 2 over 1. You cancel these 2 with these 2, so you have a 3 left. That's how you got here. All right. Okay. Now keep going. We want to see the following example. In this example, we want to see if two equations, f and g, are equal. Okay. Of course, g has the expression is x squared over x minus 1. That's x minus 1. You may cancel 1x upstairs and downstairs, because here is 1. It looks like those two quantities or expressions are the same. So it looks like they are equal. For the equal function, you also want to check the domain. Here the domains are different. For this one, any number works. So the domain is all real numbers. But for this one is different. You see right here, you cannot plug in 0 here. So that's the difference. So since the domain downstairs here is x not 0, but here 0 is included, so then you may see the two functions are not equal. Okay. Now let's see the second one. Second one is similar, because the domain right here is all real numbers. Here is all real numbers for x squared. You put any numbers here, it makes sense. But for the expression right here, you cannot really, if you look at that, you do the radical first, and then you do it to the fourth. And here you cannot plug in negative number. Okay, so that's why the domain for the second function g of x is greater than 0. Since domains are different, and functions are different. Okay, although this expression equals x squared, but you cannot put negative number here because this number is actually from here. Negative number cannot work inside the radical square root. That's the point. All right, now the last one, you may want to read that yourself. Okay, and then here I'll see you next time.